For homework 10 problem 1, it's let us to find some simple properties and definitions of some stochastic process. The first is the Poisson process, and we know that it can be defined as the numbers that falls in the interval of t1 t2 in the time of ti. So the first order probability mass we know that it is this, and the mean of this is lambda t, and the autocorrelation autocorrelation is lambda square t1 t2 plus lambda multiple the minimum of t1 t2, and the covariance is the lambda multiple minimum of t1 t2. These are the expectation is linear because if we wait longer, then there will be more bus. The second is the Poisson increment process, which the definition is like this: yt equals to this and this one, and in this expression, xt is a Poisson process. Its first order probability mass is like this, and the mean of it is lambda, and the autocorrelation we need to, because the t1 and t2 can be both positive and negative, so we need to depart it into different situations. So when t1 is bigger than t2, it is equal to lambda square, and when t1 is smaller than equal to t2, it is equal to this one. And the covariance also, we can get this one. And the third process is a point impulse process, which is defined as this. Also, xt is a Poisson process. So, because for the expression zt minus lambda, it is a white noise, which is the mean of it is 0, and the autocorrelation is lambda multiple theta t1 and t2. The fourth process is semi-random telegraph signal, which is defined for a Poisson process. We define xt equals to 1 when k is even in 0 to t interval. Xt equals to minus 1 when k is odd and in 0 to t interval. For the first order probability mass, it is equals to this one, and for the p xt equals to minus 1 equals to this one. The mean is the expression like this, and the autocorrelation is like this, and the covariance is like this. We may find that the p xt equals to 1 is not equal to 1 is not equal to 0.5, because we assume xt equals to 1, start with 1. So we can find that when t goes to infinity, this is equal to 0.5, and this is also equal to 0.5. The five process is random telegraph signal, which is defined as yt equals to a multiple xt. Xt is also a Poisson process. And in this question, the p a equals to 1 equals to p a, have the ability of p a equals to minus 1 equals to 0.5. xt is an semi random telegraph signal. So for this process, the yt equals to 1 equals to yt equals to minus 1 equals to 0.5, and the expectation is 0, and the correlation is like this, and covariance is same as a correlation. The sixth process is random walk. It is we choose a fair coin n times, and k is the number of heads in the n times. The probability mass is xnt equals to ks minus n minus k multiplied by s, which is 2k minus n multiplied by s. The probability mass we can get is the in when xt equals to xnt equals to rs is like we choose n minus r n plus r divided by 2 from the n total n times, and multiple 2 power n 1 under 2 power n. The mean of it is 0, and the autocorrelation is the minimum of m and n multiple s squared. The autocovariance is the same. So when we can see that for this expression, when n goes to infinity, it will be the Gauss density. The seventh is a Wiener process. It is defined as this expression, and x is in this expression xt is a random walk. The probability density mass is like this, and the expectation is 0. The rt1 t2 equals to minimum of t1 t2 multiple alpha, and the ct1 t2 is equals to rt1 t2. So that's all.